Surface area. This is actually an extension of 7.4 arc length in our book. What we're going to do is we're going to take the surface area, little pieces of surface area, in a volume of revolution. So we're going to take this little strip going around, and it's going to look something like this. It's a strip that's going around the volume. We're going to find the area of this strip and add it to other little strips as we go around and around this solid. Okay, so these little pieces of arc length are really finding the area of a truncated cone. What's a truncated cone? Let's take a look at this. Here's a cone, and we're going to cut off the top portion so it looks something like this. So this is the truncated cone, and when we open it up, it's going to look something like this. It's going to be a strip. Now the formula for the area of a cone is pi r/L. That's the area for the surface area of the whole cone. But remember, this is a truncated, so what we're going to do is modify the formula, and it's going to be the sum of the radii. So sum of radii are the two radii that we have. So this is radius 1, and this is radius 2. And then we're going to times it by the slant height. Now, this is our slant height. We usually call it L, and our slant height right here, from here to here, will be replaced with actually the arc length. So this arc length right here, is actually our slant height. So this portion right here represents this, and we're going to introduce a 2 in the numerator and a 2 in the denominator, and this part right here is going to represent the average of the two radii. So this is going to be 2 pi, and this is the average of the radii, so we're going to call that r. R, the radius, will be actually the average of this two, and times the arc length right here. So that's the format we're going to be using to find the surface area. We're going to take this and we're going to sum up all of the surface area. So all of these little strips are going to be added up together. Remember, one more time, the length is 2 pi r, and the width is going to be an arc length, not delta x. Okay, in future math courses, they're going to prove why this is what we use instead of delta x. All right, and here is the surface area formula. And again, this represents the radius, and this whole thing represents the arc length. All right, let's calculate the surface area of a sphere of radius r. Now, in geometry, we proved that the area of a sphere was equal to 4 pi r squared. The best I could do when you were in my geometry class was take a orange, find the radius of that orange, and draw 4 circles with that radius, and then peel it and show that all that surface, which was the peel, amounted to 4 circles. But now that you're in calculus, we're going to be able to prove it. All right, so what we're going to do is this is going to revolve around the x-axis, so that's going to make a whole sphere. These spheres are going to, the sphere is going to go all the way around, like here, and this is going to be a strip. Remember that this represents 2 pi r, and this represents the arc length. Okay, so our function, f of x, is equal to root r squared minus x squared. And you know that when we're working with the arc length, we're going to have to take the derivative. So let's go ahead and do that now. The variable is x. This is a constant. So this is going to be 1 over 2 root r squared minus x squared, and then use the chain rule, and that'll be negative 2x. And the 2's are going to cancel. This is going to be opposite of x over root r squared minus x squared. Eventually we have to square the derivative, and this will be x squared over r squared minus x squared. Okay, so let's go ahead and figure out the surface area. And the surface area's formula goes from negative r to r, 2 pi. The radius is f of x, and in this case it'll be root r squared minus x squared times, and now we're going to times by the arc length, and the arc length is root 1 plus x squared all over r squared minus x squared, and then it's dx right here. So we've squared that. Let's do some cleaning up here, and this is going to be root r squared minus x squared. I'm going to get a common denominator, and when I get a common denominator over here, I'm going to get root, and then this is going to be r squared all over r squared minus x squared dx. This is root. And then when I simplify, I'm going to have 2 pi capital R dx. And then this will be 2 pi capital R x evaluated from negative r to r. So this is going to be 2 pi, and this is going to be r squared minus 2 pi r, and then substitute the opposite of r, and when you simplify it's going to be 4 pi r squared, which is what we had taught you back in geometry. Okay, here's another example of finding the surface area around this figure. Remember, the formula for surface area is going to be from a to b, 2 pi r, whatever r represents, our function, root 1 plus dy dx quantity squared dx. So the hard part is to find the derivative. Here we have find the derivative, and then we're going to have to find this expression 1 plus the derivative squared, which we're going to get right here, and that's going to belong inside this square root. So 2 pi f of x square root of this quantity right here. Our f of x is here, so that's what we have here. And then when I put this quantity right into here, the square and the square root cancel each other out. We have this. Multiplying everything out, we get this, and we will be able to get a surface area answer. So in conclusion, let's go ahead and put these two formulas together. This is the arc length formula based on the Pythagorean theorem, altering what it looks like. And the surface area, we just have to add this idea of the length of the strip, 2 pi r, where r is the radius or the function here. So this 2 pi r is represented here, and then times the surface times the arc length, and the arc length is represented right here. And this concludes the screencast.